Hi, this is the thermal insulation required practical for triple science only. Okay, so now the whole point in this, okay, I've written it here, is to investigate the effectiveness of different materials as thermal insulators and the factors that may affect thermal insulation properties of a material. Okay, that's the whole point in the practical. Now, there are two practicals, and so what I'm going to do is I'm going to go through the first one, obviously, and then I'm going to go through the method for the second one. Right, so this is then the first one. So what you need is you need a 100 centimetre cube beaker, you need a 250 centimetre cube beaker. Right, so what I've got is there's the small beaker, the 100 one, the 250 one is then the one that goes on the outside. We've got a thermometer, we've got a kettle to heat water, we've got a piece of card that goes across the top, we've got a stopwatch, we've got insulating material, and some examples that you could maybe use are newspaper, corrugated cardboard, bubble wrap, cotton wool, rubber bands. And this is then just kind of like another version of it, right? But this one isn't as good, but what it does, it shows kind of the beaker and the thermometer with stuff wrapped up around the outside of it, right? But the one that you need to know about is this one in the top right-hand corner. So the practical itself. What you're going to do now is you're comparing the effectiveness of different materials. So this is all about different materials. So you put the small beaker inside the large beaker. Put hot water into the small beaker, right? And then what you need to do is you need to decide exactly how much you're going to be doing. So it could be 100 centimetre cubed. Put the thermometer through the hole in the cardboard. Record the temperature of the water and start the stop clock. Record the temperature of the water for every 3 minutes for 15 minutes. So you can do it for every 3 minutes for 15 minutes. That is then experiment number 1 done. Now what then happens is you repeat using different materials. And where you put the materials is in this gap in between the large beaker and the small beaker. And you also need to make sure that you put a heat-proof mat underneath your beaker to prevent loss through the bottom. Variables don't mess in class, so the dependent is what you're going to measure is the temperature change during the practical itself. Independent what you change is then the insulator, so whether it is paper or cotton wool or elastic bands or whatever it may well be. And things that then you can control is volume of the water, the time that you record, heat-proof mat underneath. Okay, so that is then the first experiment. This is then kind of a rough sort of graph that you might get. You're starting at time 0, and then what you're doing is every 3 minutes, and I said on the actual thing itself up to 15 minutes, but it could be up to 20 minutes. You start off 100 degrees C, right, which is probably not going to be absolutely valid, okay, but theoretically you're going to start at 100 degrees C, and then what you'll do is you'll have a series of graphs like this, and you can see that the orange one, which is no insulation, cools down the fastest, and then material 1 is obviously the best insulator because then it cools down the slowest. Number 2 is then the thickness of the material. All right, so what you might do is you might have paper and you wrap your paper around it, and then you put more paper, and then you put more paper. So the actual equipment itself is very, very similar, except for the fact that all you're doing is you're adjusting the type of material that goes around the outside, or the amount of material that goes around the outside, rather. Right, so with this one, go through the method. Wrap 2 layers of insulating material around the beaker. Okay, then put 80 centimetre cubed hot water into the beaker. It could be 80, it could be 100. Record the temperature of the water and start the stop clock. Record the temperature of the water every 3 minutes for 15 minutes and record your results on a table. Right, so exactly as we did on the previous one, but then the big difference now is what you do is then you repeat adding 2 more layers of insulation. Now, depending on what it is, if it's something thick like cotton wool, you might just add 1 more layer, right? But then you just keep on repeating it and repeating it. So don't mess in class. The dependent, what you measure is again temperature change. The independent, what you change is the number of layers or the thickness of the insulator, and the control then stays kind of a bit like the same. Now what I've done on here is just to kind of add a bit of interest level is double glazing, right? So what you've got here is you've got single glazing, which is a piece of glass, double glazing, right, that then lets some heat through, but then it reduces some of the heat. You've got triple glazing, which then reduces the amount of heat that's lost again, and then vacuum glazing, where what you've got then is you've got literally a layer of vacuum in between two pieces of glass. Right, so that is then the required practical, and it is a triple only. All right, and what you've got to do is you've just got to know the methods, right, and then what you've got to do is you've got to be able to explain them as accurately then as you possibly can.
So now you've watched the required practicals. Now what you've got is instructions about what you have to do. If you're unsure about anything to do with the video, then you need to go back through it. In the exercise books, don't write out the questions themselves. For shorter answers, just write out the answers that you're using in the question, and using the question rather. Longer answers, do a plan, make sure you get the right order, and then bullet point or small precise paragraphs. Don't do long reams of writing, it's not the way to do it. The questions are then on the next slide. Pause the video, and then when you've written the questions, review and see if it all makes sense.